Lesson 10.3 Trigonometric Functions of Any Angle. To help us identify or evaluate trig functions of any angle, we can use a reference angle, which is an angle between the terminal side and the x-axis. So this angle here, that's the reference angle. It always goes to the nearest x-axis. And the reference angle has the same values for the trig functions as first quadrant angles. So for example, if this angle is, say, 30 degrees, it's going to have the same values as the 30-degree angle over here. The only difference is negative signs. What's written here is what's positive. All means sine, cosine, and tangent are all positive. Sine means sine's positive, but cosine and tangent are negative in quadrant 2. In quadrant 3, sine's negative, cosine's negative, but tangent is positive. And in quadrant 4, sine's negative, cosine's positive, and tangent's negative. It's way to remember it is all students take classes. And of course the reciprocals are with their functions. So secant would be with cosine. So let's sketch our angle and then find the reference angle. So 150 degrees. So this is 0, 90, 180, 270, and 360. So 150 is between 90 and 180, and it's closer to 180, so probably something like that. The reference angle goes between that and the nearest x-axis, so that is the reference angle. To find its size, it's just the difference of our two marks. So it'd be 180 minus 150, which is 30 degrees. So our reference angle is 30 degrees. Why don't you try number 15, which is 23 pi over 4. Give you a hint. You're going to have to find a coterminal angle until you get an angle that's between 0 and 2 pi. So pause it and do that. Your reference or your coterminal angle is the same as 7 pi over 4. And the reference angle is pi over 4. All right, so now we can use reference angles to evaluate functions without a calculator. So evaluate cosine of negative 60. Well, some of you will do just fine with the negative 60. Some of you will need other help. So what I will do is I will find a coterminal angle between 0 and 360. So I will take this and I will add 360 and end up with 300 degrees. So 300 would be about there. Or if you like, also negative 60 is there also. The reference angle is here between the angle terminal side and then x-axis. So to find that reference angle would be 360 minus the 300, which is 60 degrees. So our reference angle is 60 degrees. Now what we're going to do is we're going to find cosine of 60 degrees. Well, we could use a special right triangle of 30, 60, 90. The sides go 1, 2, square root of 3. There's the 60. Cosine is adjacent over hypotenuse, so that's 1 over 2. And now you just have to figure out the sine. So this is all students take classes. So cosine is positive in quadrant 4 where this angle is. So it is 1/2, positive 1/2. If we were in quadrant 2 or 3 with the reference angle of 60, it'd be negative 1/2. Why don't you pause this and try number 25, sine of negative 150. And your answer should be negative 1/2. Our problem-solving problem for this lesson is estimating a horizontal distance of a projectile, in this case a red kangaroo, who jumps at an angle of 8 degrees with an initial speed of 53 feet per second. Alright, so you need a formula. When you're in feet per second, your distance is the initial speed squared over 32 times sine of 2 theta, where theta is the angle. So that's theta, and the 53 is the v. So our distance is 53 squared, and that has to be in feet per second, over 32. Oops. Sine of 2 times 8 degrees. Let's use my calculator. 53 squared divided by 32 times sine of 2 times 8 gives us 24.2 feet.